Okay, today we're going to talk about proving lines parallel. Okay? At the end. Okay. Who wants to read for us what this says over here? I'm sorry. Maybe it'd be hard if I could. There you go. Not that part. Here. Okay, sorry. Here we go. Is this better? Sorry. Okay, how about, go ahead. No? Oh, go ahead. You can. Okay. Just about just this part. Okay, go ahead.
In the preceding section, you saw that when two lines are parallel, you could conclude that certain angles are congruent or supplementary. In this section, the situation is reversed.
Okay, so this section, the situation is going to be reversed. Anybody want to guess what that means? Yes, sir.
If the angles are congruent or supplementary, then the lines are parallel.
Congruent or supplementary?
Some angles are congruent.
Which ones?
Certain.
Okay. All right. So okay, hold on. Here, you don't have to write this one down because we did this yesterday, right? Postulate 10. Okay. If you don't have to write this down. If two parallel lines are cut by a transversal, then corresponding angles are congruent, right? Can somebody then give me the reverse situation? In other words, what are we talking about when we say reverse situation? Converse. Can somebody give me a converse for this? 1, 2, 3, 4. Go ahead. How about Samantha?
If two corresponding angles are congruent, then two parallel lines are congruent.
Almost. Actually, we're going to start with if two lines are cut by a transversal and...
Oh, and they form congruent corresponding angles.
Yes, exactly. So it's, yeah, I see what you mean by that. But here, this is what we mean by reverse situation. Instead of having two parallel lines, we're going to have just two lines cut by a transversal. Yeah, go ahead and write postulate 11, not 10, because we wrote it. But the reason why we're showing both of these is because I want you to look at the difference. Look at postulate 11. We have two lines, not parallel lines, you see? If two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel, is what we're talking about today. It is a converse of postulate 10. Okay, now, this is a postulate, so we take it as truth. We do not prove this, okay? We take this as truth. But do you agree with this postulate? Does this make sense that this should be true? No, it doesn't? Now, if it doesn't, think about the construction we did last time. Remember, we had a line and a point outside the line. How do we construct a parallel line through that point? By copying the not any congruent angle, but which angles were they? Those? Those were the corresponding angles. So that's what this is saying, right? Didn't we copy the corresponding angles?
Yes.
So if two lines are cut by a transversal and the corresponding angles are congruent, guess what? These two lines must be parallel. Think about the construction we did last time. Isn't that what made those two lines parallel? Because we basically copied those corresponding angles. Right, guys?
Yes.
Does this make sense?
Yes.
Okay. Now, I bet you a lot of you could guess what our theorem is going to be. Because this is exactly it's really similar to what we did last time in it's now everything's the other way around. If you look at the postulate 10 and 11, just like this. Remember the first theorem we studied yesterday? You could go back to your notes if you like, but anybody want to guess what this theorem is going to say? A lot of you could guess already. Yeah, Jason, what do you think, sir?
Wait, the name or what it's going to say?
No, you don't know the name, but what will be the theorem that we're going to study next after this, you think? You're right. If it's going to start with if two lines are cut by a transversal. And that's what this one is. But the theorem from this postulate is going to be... Not sure? Nicole, you want to try? And the lines are parallel? No, this is, again, reverse situation here. Grace. That's right. If two lines are cut by a transversal, remember this is sort of the converse of the first theorem we studied last time, isn't that right? Yes. If two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Okay, so again, in this section, we're trying to see whether or not the two lines that's given to us are parallel. Does that make sense?
Wait, so what is called a theorem? What is called a postulate?
Sorry?
Wait, what's the difference between a postulate and theorem?
Postulate we don't prove, we just take it as truth. Now from that postulate we could actually prove this theorem. Let me show you how that works, okay? So here's a picture of it, and here's what's given to you. You might want to write that down, because we are going to actually prove this, okay, together. So I'll wait. Let's take a look at this. Before we prove this, there's one key step you have to show. Then you're really done. What if I could show this? Then we're really done. Again, does everybody see what is it that we need? Hint, hint. Look at what the picture has, and notice picture does not have every angle named, right? It only has 1, 2, 3, right? Those 3 angles. Okay, so if I could show this, we're done. We know that angle 2 and 1 are congruent, right? Because that's given to us. Because those are the alternating interior angles. If I could show this, then we're really done. What can we show here? Andrew? Which ones? 1 and 3, you're exactly right. If I could show that angle 1 and 3 are congruent, we're done. Why, class? Why? Yeah, actually, yeah, one. Because these are the corresponding angles, right? Then we could actually use the postulate we just had. If two lines are cut by a transversal and corresponding angles are congruent, then of course 2 lines are parallel. Now, is there a way to show that angle 1 and 3 are congruent? Amen. Exactly. Angle 2 is congruent to angle 3 because these are vertical angles. And if 2 is congruent to 3, and we know 1 is congruent to 2, guess what? By transitive, 1 is congruent to 3, and we're done. Does that make sense?
But that's not proving K.
It's not proving? You don't think it's not proving K is parallel to N? Why not? Jason, did you have a question?
Can't you just say that angle 3 and angle 1 is corresponding?
Well, just because they're corresponding angles doesn't mean they're congruent. That's only true if 2 lines are parallel. And do we know that 2 lines are parallel? No, that's not. That's what we're trying to prove. Does that make sense? So please be careful. Yeah, a lot of people, because of last night's homework, people say, wait, isn't 3 and 1 already congruent because we have, 2 lines cut by a transversal? Well, that's only true if the 2 lines are parallel. And that's what we're trying to prove. Now, Austin, going back to you, you don't think by showing angle 1 and 3 are congruent, it shows that K and N are parallel? You don't think so? And why don't you all try to prove this? I'll wait. Go ahead. Go ahead. Everybody try. As a group, you could help each other. So first, let me give you the first line. Given. Okay, so I give you that. I'm sorry. 1 and 2 are congruent. There you are. And anybody know what to write next to prove this? Oh, a lot of you. Oh, not. How about, who haven't I called today? I haven't called. Nicholas, what do you think? Angle 2 is congruent to angle 3 is correct. And what's the reason, Nicholas? Yeah, because vertical angles are congruent. Now, look what we have. Angle 1 congruent to 2, and 2 again is congruent to 3. What can we say next here? How about Kevin?
Angle 1 is congruent to angle 2.
And by?
Transitive property of...
Transitive property of congruence is correct. They just wrote transitive property again. They should have written down transitive property of congruence. Then, now that we have shown that 1 and 3 are congruent, what can we say next? Tony?
Line K is parallel to line N.
Line K is parallel to line N because?
Because if 2 lines are cut by transversal and the corresponding angles are congruent, the 2 lines are parallel.
Exactly. The previous theorem right here. Right? Austin, does that make sense? Okay, this is how we prove that if the alternating interior angles are congruent, then these 2 lines are parallel. Yeah, question?
Since we're using the postulate that says if 2 lines are cut by transversal, don't we have to state that transversal T cuts?
Well, that's a good question. How come they don't include that transversal T cuts line K and N? We sort of talked about this yesterday too. Chris? Because what? Yeah, we have the picture that shows that T is.
So if you have a picture, you don't.
Yeah, because we could assume if you have this picture, we know that T is a transversal of K and N.
So why do we write angle 1 is equal to angle 2?
Because that's.
Because it's not. Oh my god.
Wait, if you
You need it to
So something like,
Angle 2 is equal to angle.
I see. That's a good question. Because look, in the picture we have angle 2 and angle 1 congruent, right? Like for these lines, when they're intersecting something like that, you could actually assume those. But 2 and 2, you know, in order to make these thing work in logical sequence, doesn't it make sense that you want to put that given there? If you don't put it there, and you know, then for these, you don't really need that t, do you, to show that angle 1 is congruent to angle 3?
Yeah, you do.
You do?
Because line T makes them ultimate.
Oh yeah, okay. So if you want, I mean, if it makes that, if that really bothers you, you could actually write down after 1 is congruent to angle 2. You could write down transversal t cos line k and n. But it's something that's so obvious to us. It's in the picture also. That's why I didn't put that there. But if it bothers you, you could write that down. Not a problem. Yes. Question?
You know the other given?
Yes.
The transversal t thing?
Yeah.
How come we didn't use
He just
I don't know how to respond to that. Okay, who wants to? We just said, Jason, because it's on the picture, and if it bothers you, you could actually write it down in the given.
Oh, I thought that was part of Austin's answer.
Okay.
What are you saying?
Okay. Any questions? Does that make sense? May I move on?
Yes.
All right. Good. No? Question? Oh, okay. Thank you. Okay. I bet a lot of you could guess what this next term is saying. It's sort of like what we talked about last time. We first talked about the corresponding angle, and then we talked about the alternate interior angles, right? Isn't that what we did last time? Guess what's going to come up next? I bet a lot of you could guess. Yechan, what do you think?
Same side.
Yeah, what about same side interior angles? If,
Two lines are cut by a transversal.
right, and,
Oh, if two lines are cut by transversal and same side interior angles are supplementary.
it are supplementary this time, then,
Lines are parallel.
exactly right. Okay, so here's a picture. You don't have to, I just want you to write down the theorem. You don't have to copy the picture or things like this. But we are going to talk about this in terms of why this is true. So as you write down the theorem, take a look at the picture and think about how you go about proving this theorem. Okay? So I'll wait. Okay, go ahead. Here we go. So let's think about how you would go about proving this, because I may ask you to do that at some point. Turns out it's not so bad to prove that K and N are parallel. First of all, anybody see a key step in this proof? If I could show this step, you're really done. What is it that I want to really show here? How about Amy? Measurement of angle 2 and 3 equals to 180 if you add them up. That's one of the steps you need, yeah. But that would not be the key step, because from that step you can't really show that K and N are parallel, can you? You know what I'm talking about? Right? Which step do you need to show? So if I could show this step, do you want to try it again? Angle 1 is supplementary to?
Given.
Oh, wait, sorry, never mind.
Okay. Brandon, what do you think? Which step do you think is necessary to prove that the two lines? Not sure? How about Jet? Brandon, did you hear what he said? He said angle 1 is congruent to angle 3. If I could show that angle 1 is congruent to angle 3, then I'm really done. Why? Do you see why, Brandon? Yeah, turn around. Yeah, these are alternate interior angles, aren't they? And so we just said right before this theorem, right? We just proved it. If two lines are cut by a transversal and alternate interior angles are congruent, then the two lines are parallel. So you're exactly right. If I could show that angle 1 and 3 are congruent, I'm done. Is there a way to show that angle 1 and 3 are congruent?
Yes.
Josh? Sure. That's given, right? Angle 1 and 2 are supplementary. That's given. Yeah, and? Angle 2 and 3 are also supplementary, aren't they?
Yes.
Mm-hmm. Exactly. If two angles are supplementary to the same angle, which is angle 2, then guess what? These two angles are congruent. Very good. That's what you could do to prove that. That's one of the ways. There are other ways. By the way, before I could say 2 and 3 are supplementary though, if you were doing this proof, you have to state some you have to say something before that 2 and 3 are supplementary. Because as it is, you can't say that. What do you need to say in order to say 2 and 3 are supplementary? How about Samantha? Exactly. You have to say measurement angle 2 plus measurement angle 3 is 180. Then you could say they are supplementary because by definition of supplementary angles, right? Yeah. Why is it that angle, then what is the reason for angle 2 and 3 to measure up to 180 degrees? Esther? What is the reason that we have to say that angle measured up angle 2 and 3 add up to 180? What would be the reason for that? Before we say that they're supplementary. What would your reason be if you were doing a proof? Why is it that angle addition postulate, second part, you guys remember that? Yes. You have to state that, right? Even though to us it's so obvious that 2 and 3 are supplementary, right? You have to state that statement first. Does that make sense? Is there any another way to prove other than using that theorem? Yes, sir.
Is it definition of angles
For what? For 2 plus 3, could we use the definition of supplementary angle for 2 plus 3 equals to 180? No. You have to say that 2 plus 3 is 180 first. Then you could use definition of supplementary angle, right? Because you don't know that they're supplementary right now. Even though it is obvious to us, we haven't said it. We haven't said anything about 2 and 3 being supplementary. That's why we said we have to use the angle addition postulate to say that their sum is 180. Then you could use the definition of supplementary angle to say that angle 2 and 3 are supplementary, and you could use the theorem we just talked about. What's another way of proving this? Anybody see it? Well, look at angle 1 and 2, aren't they supplementary? Yes. So by definition of supplementary, I'm now talking about angle 1 and 2, Jonathan. 1 plus measurement angle 1 plus measurement angle 2 is equal to 180. What about 2 and 3? By the angle addition postulate, measurement of angle 2 plus 3 is 180, and of course you could use substitution, then say angle 1 plus 2 is equal to measurement angle 2 plus 3, and then subtract angle 2 from both sides. That will work too, if you don't want to use that theorem, right? If two angles are supplementary, the same angle, right? If you don't want to use that. Does that make sense? Okay. All right. Then let's look at the next theorem. Okay, take a look at this one here. It says, in a plane, two lines perpendicular to the same line are parallel. Okay, this one is sort of stated in a different way than last time. It's not that, but it is saying the same thing. It may not look exactly like the last theorem we talked about yesterday. In a plane, two lines perpendicular to the same line are parallel. Okay. So write this down and think about how you go about proving this. If I ask you to do that. Okay.
Wait, so we don't write given and proof?
No, you don't have to write that down. But like I said, at some point I might ask you to do it. So it may be good to really understand why this must be true. Iveta, what do you think? What do you think will be the key step? And take a look at this picture. That's a hint because they don't label every angle here, do they? But they have angle 1 and 2. How is it that we could show that K and N are parallel? If K is perpendicular to T and N is perpendicular to T. What can you say about angle 1 and 2? Supplementary. Okay, what is the measurement of angle 1? Do you think it's going to be? Huh? 90, right. What about measurement angle 2? And what kind of angles are angle 1 and 2? They are? Right angles, yeah. And also, in terms of the two lines cut by a transversal, angle 1 and 2 are the corresponding angles, aren't they? So if I could show that angle 1 and 2 are congruent, I'm done.
Yes.
Because from the postulate we learned, if two lines are cut by a transversal and corresponding angles are congruent, then of course two lines are congruent. All right, so what would you do to prove this? The first step, of course, will be write down the given, right? Right there. K is perpendicular to T, N is perpendicular to T. What do you think my second step will be? Anybody? Samantha?
Measurement of angle 1 equals 90 and measurement of angle 2 equals 90.
Exactly. By the definition of? Perpendicular line. Very good. Measurement of angle 1 would be 90. Measurement angle 2 is equal to 90 by definition of perpendicular line. What would your third line say? Yes, sir. Angle 1 is congruent to angle 2. What's the reason? Say it again. No, it won't be transitive. Not substitution. Uh-oh. Okay, we just said angle 1 is 90, angle 2 is 90. And next we said angle 1 is congruent to angle 2. Why? Because of one. No, that's later. So after we say the given, then we said angle 1 is equal to 90, measurement angle 2 is equal to 90 because of definition of perpendicular lines. And then you have to say angle 1 is congruent to angle 2 because of not one of the postulates or theorem we studied, but because definition of no, there's yeah. Some of you wrote down that on the test too. There is no definition of right angle. Well, because all it says is 90 degrees, right? So you need to say definition of yes, congruent, not congruence. Definition of
Corresponding.
raise your hand if you think you know. Yeah. Congruent angles. Because what's the definition of congruent angles? They have the same measurement. They're both 90. That's why angle 1 is congruent to angle 2. Then what can you
They're also corresponding.
so what? Because
It doesn't state that they're parallel.
exactly. Austin, you have to state that angle 1 is congruent to angle 2. If you skip that part, you haven't said that those two corresponding angles are congruent. If you want to use the postulate that if two lines are cut by a transversal and corresponding angles are congruent, you have to have
The lines are parallel.
you have to have no. If you want to, if you guys are missing this, if you want to use that postulate that if two lines are cut by a transversal, which is this picture, right? So you don't have to actually say that part, but you have to say then corresponding angles are congruent. If you skip angle 1 congruent to angle 2, then you haven't said those two angles are congruent, those corresponding angles. So you cannot use that postulate. Do you see what I'm trying to say?
You can't say corresponding angles are congruent.
Not at that point. Because how do you know that they're congruent? We don't know that. But because angle 1 is 90 and because angle 2 is 90, we know then by definition of congruent angles, right, that they're congruent. Therefore, after that, stating that angle 1 is congruent to angle 2, then you could use what? Yeah, then you could say K is parallel to N because if two lines are cut by a transversal and corresponding angles are congruent, then they are parallel. Do you understand? Do you see the logical reasoning behind it? Do you see why we can't skip the part where it says angle 1 is congruent to angle 2?
Yes.
Okay. Any questions? Yes. We just talked about the proof there. On this. They don't have proof. We just talked about it. We even told you what each steps are. We don't have proofs here. What was our first step? Given. What was our second step, guys? Measure of angle 1 is 90. Measure of angle 2 is 90. What's our third step? What's our third step? Measurement angle 1 is congruent to, not measurement, angle 1 is congruent to angle 2 because definition of congruent angles.
What justifies step 2? Definition of perpendicular.
Thank you. Then, as the last step, K is parallel to N because if two lines are cut by a transversal and corresponding angles are congruent, then the two lines are parallel. Question? Which theorem is this? Say it again. So the question is whether or not we could use this theorem. What is the theorem? Can you state it again?
Wait, what? Oh wait, like if a transversal is perpendicular to one of the two parallel lines, then it is parallel to perpendicular to the others.
No. You mean the? No, you can't because that is assuming that the two lines are parallel, right? Okay, please be careful. We don't know that K and N are parallel right now. That's what we're trying to prove. Okay? Does this make sense?
Yes.
All right. I want you to know these theorems. We're not going to be proving them, okay? We may come back to these later, like in other chapters. Okay, here we go. So, you know what? Don't write them. They're in the book because of time. Let's just take a look at it. First of all, through a point outside a line, there's exactly one line parallel to a given line. What does that sound like? Sort of. But you may use these for your homework tonight if necessary. You don't have to write them down right now. But through a point outside a line, there's exactly one line parallel to a given line. Have we done this before?
Yeah, the construction.
Thank you. It's the construction. Right here. Right here. And if you could have exactly one parallel line, well, guess what? Could you have a perpendicular line through that point? Exactly. There's going to be exactly one also. So through a point outside a line, and we've done the construction for this one also. Do you guys remember? Through a point outside a line, okay, there's exactly one line that's perpendicular to a given line. Okay. So that's sort of obvious. Any question? Okay. Like I said, you don't have to write these down. It's in the book. Okay. Let's move on. And the last term of the day. Two lines parallel to a third line are parallel to each other. Okay, so, no, you don't have to write this down. Actually, this one I want you to write. This is actually, say it again.
Can you use transitive?
That's a good question because it sounds like a transitive property, doesn't it? But do you have transitive property for parallel lines?
But they're congruent.
Are they? Where does it say they're congruent?
Because lines are on and on.
But they're not saying they're congruent, they're saying they're parallel. So we don't have transitive property of parallel or something. You know what I'm talking about? Okay, so that's what you have to prove. And but you are correct in that in order to prove that K is parallel to L and K is parallel to N, I mean if K is parallel to L and K is parallel to N, that L is parallel to N, you do use transitive, not in terms of them being parallel, but actually, this is kind of, you don't need to know this, but if I were to draw a transversal here, all throughout 3 points, then you get 3 corresponding angles, don't you? And guess what? All those 3 corresponding angles are congruent, and then you can sort of use that to transitive. But you can't use transitive to say they're parallel. But I know what you mean, because it sort of sounds like it, right? Because it's like, you know what I mean? K is parallel to L, K is also parallel to N. But that's the idea, okay? Any question? Does this make sense, by the way? If K is parallel to N, of course, and K is also parallel to N, L and N better be parallel. Does that make sense? Okay. Like I said, these 3 theorems we're not going to prove, but you may use, okay, on your homework tonight. Any question? Okay, then quickly we're going to do an example. Okay. So again, you don't have to write this down, but I want you to take a look at this, okay? This example, it says, which segments are parallel? Take a look at this. Oh, I see what you mean. Yeah, it's sort of, yeah. That's not the important part, okay? They just happen to. Now, yeah. Which of these segments are parallel? Think about it.
Did they do that on purpose?
Yeah, I'm sure they.
I know. No, just kidding.
All right, let me ask you this. Hold on. Okay, let me ask you this. How many, raise your hand. Hold on, raise your hand if you think WI is parallel to AN. Raise your hand. WI is parallel to AN. Okay, they're not parallel because this is, you can think of this, yeah, you can think of this, hold on, let me explain. If you could think of this LE as a transversal and extend WI and AN. Those are the 2 lines, right? Justin, why on WI and AN parallel? Yeah, they're not congruent. This is 61. This is 62. So they're not parallel. Okay, what about anybody have any idea then? Do you see any parallel lines? Maybe there aren't any. Oh, there are? Okay, which ones? How about Grace? HIN? But look, HI, isn't this 23 degrees and 22? They have different. Oh, those aren't the. Is 23 and 22, are they the corresponding angle? No. These are not the corresponding angle. Corresponding angle is with this transversal, LE, right? So what is sum of 23 and 61? What about 62 and 22? Therefore, HIN, TN are the parallel line. Okay. Any question? Okay, Yechan, you have a question? What is it? Let's listen. Okay, Yechan, watch this. HI, imagine HI extending to become a line, TN expanding to become a line, right? And imagine LE is your transversal. What is the measurement of HIL? No, it's not 61. It's 61 plus 23. Right? Which is 84. What's the measurement of T and L? 62 plus 22 is, again, 84. Aren't those two angles corresponding angles? Okay, so now you can see that corresponding angles of two lines that is cut by a transversal are congruent. Therefore, these are parallel. Yes, Yvette? Why isn't WI and AN parallel? Because WIL is 61 degrees, whereas ANL is 62 degrees. They're not congruent, right? Even though they look like it, they have a different angle measure. So the corresponding angles are not congruent. Therefore, these two lines are not parallel. Does that make sense? You see that?
Take out WI and
Yeah, if you were to take out WI and AN, it would be a lot easier. Okay, but that's how they try to trick you. Does that make sense? Not trick you. That's what they do to see if you really understand what these theorems are saying. Does that make sense? Any questions? Are we good?